Hey everybody, I'm Tommy, and this is video number 7 in the build series of videos for the MicroShop project. And in this episode, I'm going to show you how to make the disc sander. Whether it's your first time here, or even if you've been here before, welcome to 1 Minute Workbench. I used templates from the plans so I wouldn't have to measure anything while cutting out these discs. Each template has a crosshair where a pick can be used to create a divot in the exact center of the circle. A brad point bit will center itself in that divot, and you'll know that the hole has been drilled perfectly in the center of the template. This bearing fit a little too loose, so I reprinted the template and tried again using a different bit. This time, it was a nice snug fit. I made a circle cutting jig from one of my scraps. The slot will allow the jig to be adjusted to cut holes of different sizes. The hole in the template and the circle cutting jig are the exact same diameter as the piece of steel rod. I found this to be much more precise than just using a nail like I have with previous circle cutting jigs. Again, the slot allows the router to be adjusted to the right position. Once it was in that position, I just added a couple of screws to hold it in place. Then it's just a matter of slowly lowering the bit and making passes until you've finished making the cut. The rod would sometimes start to vibrate out of the hole, so I kept a hammer close by, that way I could tap it back down when necessary. The steel rod is also a fairly snug fit for the center of this bearing, which helps to get an accurate cut, and will also come into play later on when it's time to center this disc. You'll see what I'm talking about in just a little bit here. Notice that the hole doesn't go all the way through on the largest disc. Using a ruler helped me to locate a nice straight section of this steel rod. I then cut the rod and gave it a light polishing to remove any residue from the factory. I drew a mark that correlates to the top surface of the smaller disc and then cut a circular groove just below it. Then I realized that I actually needed the groove just above it. Again, this will make sense a little bit later on. I then cut 4 straight grooves with a length that is equal to the thickness of 3 pieces of plywood. I promise this will make sense very soon. As I mentioned earlier, the bearing helps to center the disc. Because the holes are the same size as the rod, you just need an L square to get the rod straight, and then you know that the disc has been perfectly centered. Once it was centered, I traced the smaller disc. The bearing's job is done, so it gets removed at this point. This is the epoxy to use. Don't use anything else. Seriously, even the expensive marine grade stuff will fail. I'll add a link in the description below with more information about this. Notice that when applying glue, I left a void space around the epoxy. This is so when the glue squeezes out, it won't interfere with the epoxy. The trace I drew earlier makes it easy to recenter the smaller disc. The shapes I filed into the end of the rod get covered with epoxy. The circular groove keeps the disc from pulling off the end of the rod. And the 4 straight grooves will apply the rotational force necessary to spin the disc. The third and final disc is used to make the rod perfectly perpendicular to the disc assembly. An L square is used to set the rod straight, and then pins are fired to lock the disc and the rod in that position. Here you can see light getting through near the bottom, which means the rod is leaning just a little bit to the left. By applying pressure to the right and firing some nails, again, the disc locks the rod in that corrected position. So I just continued this process until the rod was perfectly straight all the way around, and then fired enough nails so that it could no longer be moved at all. I then applied clamps, checked one last time, and let it cure for a whole day. The epoxy expanded a bit, so I removed it with a chisel. And of course, I checked it one more time. And just for fun, I decided to take it for a quick spin. With the disc on point, I started working on building a bearing block from scraps of wood. These pieces make up the mounting structure for the block. These pieces are built up in layers so that when the disc is installed, the face of the disc will be almost flush with the wall of the cabinet. The bearing block is also just simple rectangular pieces that have been stacked up. I drilled holes that were slightly deeper than the bearings. This is so that when the disc is up against the block, it won't actually make contact with the bearing. I then drilled a smaller hole all the way through the block. Now, in an ideal world, the holes I drilled for the bearings should be directly across from each other, but I did not actually achieve that. Although you cannot see it here, I could clearly see that the disc was not aligning with the bearing block. So I removed one of the bearings and added a new bearing to a new strip of wood. I then added the bearing block to the disc assembly, and then added that new strip of wood to the block. Again, using an L-square, I was able to push and pull the new strip until it was perfectly aligned with the rest of the assembly. I added some screws to hold everything in place while the glue was drying. I centered the disc in the cutout as close as I could just by eyeball, and then clamped it in place with some scraps of wood. This made it so that I could install the bearing block without having to measure anything. I used a hacksaw to customize the length of some screws and then screwed the block in place. The wheel was slightly out of balance, so I marked the heavy spots and then removed material as necessary. This process was a bit tedious, as you can probably tell from all of these drill marks, but it wasn't that bad, and I eventually got the wheel to be fairly well balanced. Now that the bearing block and mounting structure had been finalized, I cut the shaft down to its final length. Using scraps, I built a mounting platform for the drill with relatively arbitrary dimensions. Although I did measure the piece that determines the height of the drill to make sure it would align with the disc. I installed it using some screws and then decided that it also needed a back leg for more support. For the next part of the project, I again used a template from the plans. Notice here how I'm using the fence to make sure the edge of the paper is perfectly aligned with the edge of the wood. And here I was careful to slowly sneak up on the dimension and make sure my cut followed the template perfectly. Luckily, I had already built the jigsaw table, so cutting these curves was much easier than it would have been otherwise. Once again, I used the template crosshairs and a pick to make sure the holes were on point. And I made a new circle cutting jig that would allow me to use the router to cut circular shapes while the router was still installed in the table. Cutting the arcs in these small pieces would have been very difficult, if not downright impossible to cut with the jig I had created earlier. Though I didn't show it on camera, the holes in this piece were also made following a template because the position of these holes are critical. I installed T-nuts in these holes as well, and since I couldn't fit a hammer in there, I just used the knobs and lots of force to pull them into position. I removed the disc and added these washers along with some wax to help keep things lubricated. These washers will provide function similar to that of a thrust bearing. I added the outside table support wing so that it was square to the cabinet. And with a miter gauge set at a perfect 90 degrees, I used it to set the inside wing at the same level as the outside wing. I applied glue, nails, and screws. I then re-squared the inside support wing and attached to the table. I like to use screws to keep the project going quickly, but the wings were too thin to accept screws. That said, I just used glue, pins, and about 25 pounds of weight. With the table complete, I swapped out the oversized bolts I had been using with smaller ones, but I couldn't get over the fact that the threads were going to slowly wear the material away. So I decided to make some custom pins out of the leftover steel rod. I used a little bit of oil and cut threads into the rod that matched the threads of the T-nuts. As usual, I used a file to take off any sharp edges. Then I made another one. And finally, I cut a slot into the end so that I could use a screwdriver to install them. I used a hose clamp around the trigger of the drill to control the speed of the disc. I applied the adhesive sanding disc, but I should have taken the time to apply polyurethane to the disc first. You'll see why later on in this series. Because I was working with lots of small pieces, I only had the drill at about 30% power, just in case one of my fingers decided it wanted to get too close to the sanding disc. On some of the larger pieces, I had it up at around 75% power, but I never really felt the need to turn it all the way up to 100. Even at 75%, it was taking off material plenty fast enough. I had sanded pretty much every piece I could think to sand, and then it hit me. I needed to sand the sanding table. So I removed the table and built a temporary table using clamps and scraps of wood. And that's going to do it for this video. Be sure to check the description section for upcoming videos in this series. Hey, thanks for watching. I really hope you enjoyed this video. If you haven't already, be sure to like and subscribe, and make sure you hit the bell icon. That way you get notified every time I put out a new episode. I'd love to hear what you think of this thing down in the comments section. And if you have any quick questions you want answered, hit me up on Instagram, Facebook, or Twitter. And until the next time I see you, I hope you have fun building something.